Okay, good afternoon everyone. So, thumbs up kung narinig niyo ako. Okay, great. Thank you. So, last time, nagsimula tayo ng discussion natin tungkol sa machine learning and in-apply natin yung machine learning on a simple set of data. Okay, ang isang advantage ng machine learning is that you can use it to handle a large amount of data. Okay, and yun yung actually magiging focus natin ngayong araw. So, last time, ang diniscuss natin ay tawag dito, linear regression, at yung data set natin is just a simple X and Y data. Today, ang i-discuss natin ay yung multivariate na data, meaning maraming data set or maraming data points. Okay. So let's see. Share ko lang yung screen. Okay, so okay. So anong nakikita ninyo? Yung itong multivariate linear regression na slide ba? Tama lang. Okay, sige, tama. Okay, so yung diniscuss natin last time ay itong single feature na linear regression. So from this point on tatawagin natin tong dataset natin as a feature. Bakit natin siya tatawaging feature? Kasi um, yung y dito, di ba, yung y is the dependent variable and it's dependent on the x, which is the independent variable. So nagde-depend yung y dun sa kung ano man yung values nung x. So x is actually a feature of y. So kung ano man yung features na available na pinaprovide ng x, okay, ay tawag dito, magkakaroon ng effect dun sa y. Okay, so pwede rin natin tawagin na yung x is the input and then yung y ay yung output. So this is the simplest type of data set na pwede nyo i-handle gamit ang machine learning. Of course, I mean, overkill naman kung gagamitin nyo lang ang linear regression, ang machine learning para sa linear regression, di ba? So, in some cases, okay, yung data set kasi ay nagde-depend, yung output ay nagde-depend sa maraming features. Okay? So, for example, dito sa dataset na to, itong dataset na to is a multi-feature data set. Ang dependent variable dito, ang independent variable dito ay itong miles per gallon. Tama ba? Yung miles per gallon. Ibig sabihin yung consumption nung kotse. Okay? Consumption ng gasoline ng kotse. At nagde-depend yung consumption ng gasoline ng kotse dito sa variables na ito. Sa acceleration, sa cylinders, sa displacement, sa horsepower. Okay? Of course, hindi siya nagde-depend sa model, hindi siya nagde-depend sa origin. Okay, nagde-depend din siya definitely sa weight. Okay, and it could be na mag-depend siya dito sa model. Pero itong model kasi incorporates itong ibang mga features na ito. Okay, so we can say na 1, 2, 3, 4, yung weight is 5. Okay, yan yung mga independent variables. At lahat ng mga features na yan lead to kung gaano ka tawag dito, gaano kalakas yung consumption ng isang kotse. Okay? So, yan yung Yan yung ibig sabihin ng multi-featured na dataset. Marami mga features that lead to a particular output. Okay, now if we scroll down, so by the way, this dataset is available in MATLAB. So makikita niyo yan mamaya pag nirun natin yung code. Now if we scroll down dun sa code, makikita natin na hindi lahat ng output, or actually may mga data na hindi available. Like for example, dito sa rows 11 to 15, yung miles per gallon ay hindi available yung data. So meron siyang data point and not a number. So merong paraan para linisin yung dataset niya, both in MATLAB at saka in Python. So papakita ko yan mamaya. Okay, so ang una nyo actually gagawin when you have this type of dataset is to clean the dataset. Remove yung mga tawag dito variables o mga features na walang numbers. Okay, now we can describe a multi-featured dataset in the same way na diniscribe natin yung dataset for linear regression. Okay, so sa linear regression, which is a single featured dataset, okay, sinabi natin, meron tayong hypothesis. Di ba? Ang hypothesis natin is h sub theta of x equals sa theta naught plus theta 1 x. Okay. Yung theta naught ay tinawag nating y-intercept at yung theta 1 ay tinawag nating slope. Okay. Now, in machine learning language, itong mga theta na ito ay tinatawag natin na bias. Okay? Sorry. Yung theta naught ay tinatawag natin na bias at itong theta 1 ay tinatawag natin na weight. So, for each x, merong corresponding na weight. And dahil dito, ito ay multi-featured na dataset. Ito ay isang x value. Ito ay isang x value, x value, x value, x value. Okay. Okay, so ito yung mga x values. So meron tayong x parameters or x features, 5 x features leading to y, a single output. Okay, 5 input leading to a single output. So bawat isa sa mga x na yan, bawat isa sa mga features ay bibigyan din natin ng corresponding na weight. So ang mangyayari sa ating hypothesis is that okay, so yan, bawat isa sa mga x na yan ay mag-lead sa isang output y. So ang mangyayari sa ating hypothesis ay i-rewrite natin siya in terms of this equation. So theta naught plus theta 1 of x1, theta 2 plus theta 2 x2 plus theta 3 x3 plus theta 4 x4 plus theta 5 x5. Napansin nyo na bawat isa sa mga x, so ito yung, for example, if this is x1, meron din siyang corresponding na weight. Kung ito yung x2, may corresponding siya na weight. Kung ito yung x3, corresponding siya na weight. x4 may corresponding na weight na theta 4 at yung x5 ay may corresponding na weight na theta 5. Now, kung napansin nyo din, naglagay tayo ng x naught dito. Okay? In essence, yung x naught na yan is just equal to 1. Okay? Kasi pag naging equal yan sa 1, then theta naught plus theta 1 x sub 1 lang. Di ba? Pero nilagay natin yung x naught na yan para masulat natin itong buong equation na to in summation notation. Okay? So, tulad ng sinabi ko kanina, ito ay bias at ito yung mga weights niya. Okay, weights ng bawat isa sa mga features. Tapos itong x naught, okay, which is just equal to 1, ay sinulat lang natin para maisulat natin itong buong hypothesis into a summation notation. Okay, so, by the way, when we refer to specific values, okay, sa table na ito, we usually identify yung superscript as the row element. Okay, so for example, itong value ng x1, which is the first column, okay, fourth row, so first column, fourth row, okay, is equal to 12. So, itong 225 is the the ninth row, fourth column, okay, value of x. Okay? So ganun yung ano natin, yung notation natin dito. So pag superscript with a parenthesis, nagko-correspond yan sa row. And pag subscript, nagko-correspond yan sa column. Okay. So ngayon, pwede na nating tignan kung ano yung magiging itsura ng gradient descent pag multi-featured na data. So again, we write this hypothesis, okay, for n data points or for n tawag dito, for n number of rows. Okay. Actually, for n number of rows, okay, medyo confusing yan. So let's see, baguhin ko na ngayon para dali palitan ko para hindi makakita. Okay, so for m rows, okay, yung m signifies the number of rows. Okay, now we can write yung cost function natin. Remember that the cost function is a function of theta naught, theta 1 hanggang theta sub m. Okay, we can write it as 1 over 2m sum from I equals to m. Okay, lahat ng rows na yan, m is the number of rows. H sub theta, x sub I, x super I, ito yung hypothesis, which is exactly this equation, minus yung real na data set. And then square natin yan. If we compare it to the previous cost function for a single feature data set, ito yung itsura niyan. Ito yung pinag-aralan natin last meeting. Nakikita nyo na walang difference. Okay? Walang difference pagdating sa notation. Ang nagbago lang is itong h sub theta. Yung h sub theta before, dahil single featured siya, is theta naught plus theta 1 of x. Pero dahil dito, multi-featured na, yung h sub theta dito is this whole equation. Okay? Ganun pa din yung treatment natin. Bawat isa sa mga x data, subtract natin, or bawat isa sa mga x data na yan, multiply natin by yung weight. Okay, tapos yun yung magiging hypothesis natin. Then yung hypothesis will be subtracted from the actual data. And then square natin yan. Tapos isum natin lahat ng errors. Okay, lahat ng errors. Then divide natin by 1 over 2n para ma-normalize. Okay, so precisely the same as before. Okay, so again, ulitin ko lang. So, ang mangyayari is, yung h sub theta ay magiging theta sub 1, x sub 1 para sa lahat na to, plus theta sub 2, x sub 2, plus theta sub 3, x sub 3, theta sub 4, x sub 4, plus theta sub 5, x sub 5. Okay, minus yung y na data set. Okay, tapos square natin yan, the sum, and then 1 over 2n. So, ganun natin i-treat itong data na ito. So, of course, to implement yung gradient descent, kailangan natin kunin yung derivatives. So, for single feature, ang ginawa natin before, kinuha lang natin yung derivative ng cost function with respect to theta naught, tsaka derivative ng cost function with respect to theta sub 1. Yung derivative ng cost function with respect to the bias is simply written as this. And yung derivative ng cost function with respect to the weight theta 1 is written as this. So this is nothing new. Ito rin yung equation na ginamit natin before sa previous na meeting. Okay, we're just going to rewrite it, okay, in this way. So nilagay na natin tong I as a superscript. Okay, kasi this I, remember, signifies the row number. Okay? So kaya, and sinabi natin na pag superscript, yun yung row number. So, nilipat lang natin yung I at ginawa natin siyang superscript. Okay, so nagpalit lang tayo ng notation, in other words. Okay, now, to generalize, etong H dito is now written as a sum, in summation notation. Okay? So, isa-sum natin lahat ng rows. Kaya dito yung J corresponds to the row. So, J equals 1 to the nth column. Sorry pala, column. J equals 1 to the nth column. Okay? Isa-sum natin lahat ng theta J times x sub J to the I. Okay? X sub J super I. Okay? Minus Y sub super I. Okay? Ito ngayon yung ating times x sub j super I, and then isum natin lahat yan times 1 over m. Ito na ngayon yung ating derivative ng cost function with respect to the weights. Okay, so ito, in other words, will be replaced by this whole equation. Okay, now ito na ngayon yung ito na ngayon ang lahat ng kailangan natin para sa gradient descent. Yung hypothesis, yung cost function, okay? Okay, remember that the hypothesis now is written in summation notation. Ito yung hypothesis natin written in summation notation. Okay, ito ngayon yung derivative ng cost function, okay, with respect to theta sub I, okay? Pag j equals 0, yun yung bias natin, di ba? Bali, essentially, ito yun. Okay, pag j equals 0, yan yung bias. So, ito ay equal sa 1. So, yun yung sinasabi niya dito. Ito ay equal sa 1. Multiply na natin by theta naught, which is the bias. So, ang procedure lang basically is hanapin natin yung theta sub j. Okay, by from the previous value of theta sub j minus yung alpha. If you recall, yung alpha is the learning rate times yung gradient. Okay, with respect to theta sub j. At gagawin natin itong iteration na to for all of the weights, for all of the features. Okay. Okay, so ano ang nangyayari dito? Okay, tignan natin yung nangyayari dito. Theta sub j, xj. Okay, isa-sum natin muna lahat yan. Saka natin isusubtract dun sa y sub I. Okay? Wait. Dali lang. Okay, tama. Okay, so sum muna lahat nito, saka natin subtract sa y super I. So anong ibig sabihin nito? Theta, halimbawa, theta sub 1, halimbawa j equals 1. Theta sub 1, okay, x sub 1 super I. Okay, so halimbawa, first row, first column, and then yung ith row. Okay, so ganito yung mangyayari dyan. So kung meron tayong table, ang mangyayari dyan is this. Okay, theta naught. Okay, so theta naught. So multiply natin to by theta naught times 1. And then multiply natin to by theta 1, itong 12. And then multiply natin to by theta 2, itong 8. And then itong 307, multiply natin by theta 3. Itong 130 by theta 4. And then itong 3,504 by theta 5. Sa sum natin lahat yan yung summation, di ba? And then isusubtract natin yung result dito. Okay, tapos saka natin isi-square. Okay? Yung difference nito at saka nung sum nito with the weights, yan yung error. So, isi-square natin yung error. Okay? So, bawat isa sa mga row na to ay merong error. So, may error 1 ka dito, error 2, error 3. Ngayon, isa-sum natin lahat ng errors na yon. Okay? Yun yung ibig sabihin ng hanggang dito. Okay? Sum lahat ng errors. If we're solving for, and then mag-divide natin by the number of, tawag dito, columns, number of rows. Okay? Now, if we're solving for the bias, for the weights, kasi dito meron ka ng x sub j sub I, diba? Ang mangyayari is, so is-sum natin muna lahat yan. Sum natin ito kasama yung mga weights, di ba? Okay, and then, i-multiply natin by x sub 1 kung ang hinahanap natin is theta 1. Okay, so yung multiply na, again, theta naught times ito, theta 1 times ito, theta 2 times ito, theta 3 times ito, theta 4 times ito, times theta 5 times ito, minus this, okay, and then multiplied by, halimbawa, 12, okay, tapos, divide by the number of rows para makuha yung derivative with respect to theta 1. Okay, para makuha yung derivative with respect to theta 2, i-multiply natin yung nasa parenthesis by 8 and so on and so forth. So in other words, ang ibig ko sabihin, itong x na to, okay, will depend kung ano yung ginagamit natin na minumultiply na, kinukuha na natin na derivative. Okay? So ganun yung idea. Okay? So yun yung paraan ng pag-implement ng gradient descent. Of course, it will be easier kung tawag dito, gagamitan natin ito ng matrices. Diba? So, paano natin ngayon gagamitin yung matrix dito? Okay, so, we write the hypothesis in this form. Okay, now, we can write theta, okay, as this, okay, in matrix notation, okay, as a column matrix, and x also as a column matrix. Okay? Tapos, kukunin natin yung transpose ng theta. Bakit natin kukunin yung transpose? Kasi hindi natin pwede i-multiply itong dalawa, di ba? Para ma-multiply natin itong dalawa, kailangan mo muna kunin yung transpose ng matrix na ito para ma-multiply siya dito. Right? So, theta transpose of t, so transpose muna nito, multiplied by x. So, ito na yung transpose ng theta, ito na yung x. So, mangyayari is theta naught times x naught, theta 1 times x1, theta 2 times x2, and so on and so forth hanggang sa theta sub n times xn, which is essentially this. So, yan na yung hypothesis natin. Okay, how do we apply that dito? Okay, so, ang theta, ang buong hypothesis natin ngayon is theta times yung x natin. Now, dito, ang x represented by a single column. But actually, sa data set natin, ang x is represented by 1, 2, 3, 4, 5 columns. And if we include the bias, then 6. Diba? So, theta, okay, theta naught times, diba? Theta naught times x naught, okay, which is this one, for example, theta 1 times x1, which is this one, hanggang sa theta sub n times xn, which is this one. Okay, so, bali, ito na yung ginawa. Ito yung transpose ng theta multiplied by this as a matrix. Okay, so ito ay matrix na. Now, kung napansin ninyo, essentially, tinranspose din natin yung x natin. Kasi kanina, yung x nakaganito, di ba? Bias, acceleration, cylinders, displacement, horsepower, weight, mpg. Okay, so medyo ano rin siya, na transpose din siya kasi nandito na sa naging row actually yung bias, acceleration, cylinders, displacement, horsepower, weight. Okay, tapos ito ngayon yung dating rows, ito na yung naging columns. So, naging 7 by 392 na ito na array. So, mas madali yun gawin kasi 'di ba this is 1 by 7, 1 row by 7 columns, a matrix with 1 row by 7 columns. Tapos ito ay matrix na 7 rows by 392 columns. Siyempre, pag binultiply natin sila, magkakaroon tayo ng 1 by 392 na matrix. Okay, yun na yung hypothesis natin. Okay, so yung hypothesis is then given by this. So, ito, okay, itong theta sub t of x minus y. Theta sub t of x minus y. Okay, so ganyan yung tawag dito, ganyan yung hypothesis. Okay, so pag pinlog in natin ngayon yung hypothesis dito, okay, makukuha natin yung cost function and then makukuha rin natin yung derivatives nung cost function. Okay? Okay. Okay, so remember na yung MPG, ito yung ating y. Okay. Sige, tuloy lang natin to. Now, let's see how this is implemented sa MATLAB. Now, itong part lang na ito, okay, this is remember na kinuha natin yung transpose ng theta, di ba? Theta transpose. In MATLAB, it's theta tawag dito. Anong tawag dyan? Single quotation. Theta single quotation. Okay? Multiplied by x single quotation or x transpose. So, teka, bakit ito nagkaroon ng transpose? Kasi nga, kanina, pinaliwanag ko na yung data is presented as this. Okay? Ito yung actually yung x. Kukunin din natin yung transpose nito para maging ganito. Para maging 7 by 392 siya. Para pwede na siyang i-multiply with the 1 by 392, 1 by 7 na matrix. Okay? So, kaya dito, may transpose ito. And then itong y, kukunin din natin yung transpose niya. Kasi remember, yung y originally was, okay, itong y na to is a 392 by 1 column. Eh gusto rin natin na 1 by 392, di ba? So, kaya ikukunin din natin yung transpose ng y. Kasi yung product nito is 1 by 392 at ito gusto natin gawing by 1 by 392 din para masubtract natin sila sa isa't isa. Okay, so 1 by 392. Now, ito is just simple na matrix tawag dito multiplication. Remember na pwede nyo essentially ilabas yung transpose, pero pag nilabas nyo yung transpose, kailangan yung baliktarin nito. So, matrix x multiplied by matrix theta, close parenthesis, and then kunin nyo yung transpose. Okay, it's the same as this. Okay, minus y transpose. And ganun din, pwede nyo ilabas yung transpose, pero hindi nyo na kailangan baliktarin ito. So, pwede nyo na ilabas yung transpose yun. So, x times theta minus y, and then saka nyo kunin yung transpose. Okay? So, this is a simplification of this. Okay? Now, dahil nakuha na natin yung loob nitong square brackets, sasum natin siya, di ba? Square muna natin, and then saka natin isa-sum. Okay, in this case, hindi na natin kailangan ng transpose kasi itong dot na ito before the operation means na ito ay tawag dito element by element na multiplication. Okay. Now to get the cost function, syempre kukunin natin yung tawag dito, di-divide natin siya by 1 over 2m. So ito na yung cost function natin. And of course, we're going to make a function out of that. So yung cost function na may input na x and y, ito yung data natin. And then input din natin yung theta. Okay? Tapos yung m is just computed from, the number of rows is just computed from the length of x. It can also be the length of y. In MATLAB, it's precisely the same. So yung cost function is written as this. Sum ng power ng tawag dito ng dot product ng x tsaka theta minus y. Okay, this is reshaped to m1 para lang maging 392 by 1 na matrix. Okay? So, ito yung para sa Python. Okay, now, paano natin implement yung gradient descent ngayon? Okay. So, yung derivatives, alam natin is given by this equation. So, again, itong nasa loob ng brackets is essentially ito, yung dinescribe na natin kanina. I-multiply natin siya by xi, by x sub j, super I. So, ito yon. Okay. And then, multiply natin by 1 over m. Okay. So, yan yung gradient nung theta. Okay, so we can get the next theta, okay, from this equation. In MATLAB, this is how it's implemented. Yung A dito is the learning rate. And, syempre, gagamitin natin ngayon yung theta. Ipapasok natin ngayon yung theta dun sa cost function na function. Okay, so gagawin natin to for many epochs hanggang sa ma-minimize yung cost function. So, essentially, ito na yung gradient descent natin na ito yung paraan ng pag-implement ng gradient descent. Okay. Okay. Now there's one more thing before I show you yung MATLAB na code. There's one more thing na importante tawag dito para mapabilis yung pag-approach nung cost function to gradient descent to the minimum value or to the optimum value, and that is called feature scaling. From research, okay, mas maganda na i-rescale lahat ng mga input features, okay, in such a way na yung values ng x is between -1 and 1. Okay, it turns out na mas mabilis yung pag-converge ng cost function if we do this feature scaling. Okay, so to do this feature scaling, we just create a function called feature scale. Okay? At if feature scale natin lahat nung x. So essentially, lahat kukunin muna natin yung mean value ng x. Okay, so ito yon. And then yung standard deviation ng x, ito yon. Delta x. And then yung bagong values ngayon ng x na feature scaled will be x minus yung mean value divided by standard deviation. Okay, so this will give us a feature that has values between -1 and 1. Okay? Okay, so yun yung nangyayari dyan. Okay, any questions so far? Okay, so share natin ngayon itong MATLAB. Okay, so this is yung MATLAB implementation ng multivariate linear regression. Okay? Itong dataset na ito is available in MATLAB. It's one of the many sample datasets sa MATLAB. So pag click nyo to, okay, pupunta kayo sa website, okay, para makita nyo kung ano yung mga iba't ibang dataset. Okay. Okay, so yan yung kinlik ko yon, ito yung lumabas na mga dataset. So ito yung isang dataset na available sa MATLAB. So lahat ng mga ito ay available sa MATLAB. Pwede niyo nang i-call yan kahit na wala sa folder ninyo. Hindi niyo na kailangan i-download sa folder. Okay, so yan yung yan. So yan. Anyway. So let's go back dun sa MATLAB. Okay, so ang gagawin lang natin is i-load lang natin tong dataset na to kasi nga pre-loaded na siya ng MATLAB. Okay, at ito yung lalabas. Okay? So, itong buong procedure na ito, basically, tawag dito, lilinisin niya lang yung mga next procedures dito, lilinisin niya lang yung dataset. Okay, we don't have to go through that. Pwede nyo gawin to on your own. Okay, doon na lang tayo sa mas relevant. Okay, so anong ginagawa dito? Okay, ipa-plot. So ipa-plot niya. Yan, okay. So dito pinlot yung iba't ibang features against the dependent variable. So, halimbawa, yung acceleration. Yung acceleration is plotted against miles per gallon. Yung cylinders is plotted against miles per gallon. Okay, so pinlat lang dito yung iba't ibang features against the output y. Tapos ito naman yung feature scaling. Okay. Okay, ginamit natin yung function na feature scale. Kung papansin nyo, yung mga values ng x ngayon, okay, remember ito yung 1, 2, 3, 4, 5, yan yung mga x values. Okay, so they are, tawag dito, within the range of -1 and +1. Okay, may mga iba na lumagpas, pero at least malapit siya sa 1. Kumpara sa previous values niya na ito, 6, 198, 95, ganyan. Ito, 2,000, yan, malaking problem talaga yan. Pagdating sa pag ni-run nyo yan, okay, so dahil lang dito babagal lang, magiging mabagal yung pag-run nyo ng code. Okay, so ngayon feature scale natin sila, ito yung mga lumabas. Okay, so okay lang to kahit na hindi siya talaga eksaktong -1 to 1. Okay, so ito na yung bias column, ito yung theta knot. Okay. Yan, so ito na, meron ng bias column. So naging 392/7 na siya. Okay, and okay. Tapos, ngayon implement na natin yung gradient descent. Now, remember yung theta, okay? Yung parameter na theta, kung nalala niyo yung gradient descent na MP, yung meron kayong initial na guess. And din sa previous na lesson natin, sinabi natin na yung theta ay yung initial na guess natin. Kaya dito, ito yung initial guesses natin. So yung theta ay nagbibigay muna tayo ng initial guess for theta. Okay, yun yung ipapasok natin dito sa gradient descent na function. Okay, kaya dito may theta. Okay, tapos ipapasok natin itong x and y na data set. So lagay natin yan dito. And then of course, nagdagdag ako ng ibang parameters sa loob ng gradient descent which are yung learning rate at saka yung number of epochs. So sinet ko yung epochs to be 10,000 and yung learning rate learning rate to be just 0.001. Okay, so ito yung ating gradient descent. Now, yung function ng gradient descent is this. Okay, ito yung pinakita ko rin kanina. Andi dito yung pag-compute ng cost function. Ito yung nakita natin kanina na ano tawag dito na implementation ng gradient descent. Ito yung implementation ng cost function. Okay, at ito naman yung feature scaling. Okay, so pag ni-run natin tong section na ito, okay, so pa-plot natin of course yung cost function as a function of the number of iterations. And tulad nung sinabi natin last time, di ba, ang gusto na talaga nating mangyari is babagsak yung cost function and then mag-stabilize siya kapag ganyan. Okay, so ito yung ideal na result na gusto natin for a cost function. Okay, so now tignan natin yung results. Okay, so ito yung na-compute niya na tawag dito na theta values. Okay, so ito yung according to the model, ito yung optimum values ng theta. Okay, tapos train model. Okay, so anyway. Okay, anyway, so ito yung na-resolve niya na features. Okay, so anong sinasabi niya rito? Ang sinasabi niya rito basically is ito yung 1, 2, 3, 4, 5. Ano tong 3? Yung third na feature, ano bang third na feature? So balikan natin. 1, 2, 3. Yung displacement, okay, ito yung may pinakamaliit na weight. Okay, so ibig sabihin hindi ganong nagde-depend sa displacement yung miles per gallon. Okay, yung consumption ng ano. Ano yung may pinakamalaking tawag dito dependence sa weight? Itong 46, this is the bias. So hindi yan significant. May pinakamalaking contribution is this 39.79, which is the second column. The second column is the cylinders. So yung tawag dito, yung miles per gallon, okay, yung consumption ay nagde-depend sa number of cylinders. Okay, so malaki yung dependence niya sa number of cylinders. Okay, so yun yung sinasabi nitong ng model na ito. Okay, so that's how we do a multi-feature na tawag dito, learning using linear regression as a tool. Okay. Now, so yun, nakita nyo na yung isang type ng machine learning using linear regression. Okay, now let's take a look at one of the tawag dito, one of the applications na talagang pinagagamitan ng machine learning, which is classification. Okay, so siguro nakita nyo na sa internet na, di ba, ang dami mga ang target ng mga machines ang target ng mga nag-aaral ng machine learning or AI is to identify objects, okay? And in order to identify objects, so kailangan nyo siyang i-classify. Okay, so but it's not just identifying objects, okay? If you take a look at for example, a feature, gusto niyo makita yung pattern dun sa isang feature, yun din yung isang use nung machine learning or AI na tool. Okay, so ngayon pupunta tayo dun sa tinatawag na classification. Okay. So first, yung pinakasimple, binary classification. Pag sinabing binary, dalawa lang yung pagpipilian ninyo. Sa either a yes or no, it's either a dog or a cat, high, low, or it's either na yung isang picture ay pinapakita yung tao na naglalakad or tumatakbo. Okay, one of the simplest example or one of the most common examples then is, for example, itong tumor. Okay? Meron halimbawa itong dataset na ito. Okay, itong dataset na ito tells us na pag maliit yung tumor size, hindi siya malignant, pero pag malaki yung tumor size, malignant siya. Okay, so here, naka-classify na natin siya ng tawag dito, ng maayos based on the tumor size. Now, how do we implement this using ML? How do we use ML para i-classify itong kung malignant yung tumor or hindi? If we use linear regression, obviously, magfe-fail tayo. Okay? Kasi yung linear regression will give us this value. Or will give us this best fit line. Okay? So, halimbawa, sabihin ang tumor size natin is this value. Pag ginamit natin yung model natin sa linear regression, ito yung ibibigay niya sa atin. Sabihin niya na, okay, merong 40% chance na malignant siya. Kung halimbawa, ang tumor size as this value, tapos ito yung model natin, yung kulay blue, okay? Ang sinasabi ng model ay meron siyang 70-80% na probability na malignant siya. Okay, so pwede natin gamitin ng linear regression but it's not really exact. Okay? We can tawag dito, do a number of things sa linear regression, di ba? For example, pag nagdagdag tayo ng data dito, okay, ang manggagawin ng linear regression is this. Okay, so ngayon, yung interpretation natin for this ay mag-iiba na, bababa na, di ba? Interpretation natin for this tumor size, mag-iiba na rin yung value dahil lang nagdagdag tayo ng data point. So, hindi ganon ka-accurate yung linear regression na model pag gusto nating mag-classify ng objects. So, we're going to use another type of tawag dito, model para sa classification. In other words, yung hypothesis natin will have to change. Okay, hindi na natin pwedeng gamitin yung linear regression na hypothesis. So ang hypothesis na gagamitin natin is called a sigmoid or a logistic function. Now, basically ang sigmoid logistic function is this. Okay, ang hypothesis is, okay, if the value of the hypothesis is less than 0.5, then y equals 0. The given output of 0. If the value of the hypothesis is greater than or equal to 0.5, then yung output is 1. Okay? So, ang kinaganda dito is that yung tawag dito, yung hypothesis natin will always be between 0 and 1, which is what we want pag gusto natin mag-classify ng objects, di ba? Kung binary yan, it's either 0 or 1, either malignant or hindi, di ba? So, yan yung ideal na tawag dito na hypothesis, the sigmoid logistic function. Now, how does this look like? Okay, so the sigmoid function actually looks like this. Okay, so it's symbolized by g of z equal to 1 over 1 plus exponential minus z. Okay, ito yung z value. Okay, ito yung g of z natin. Okay, note na yung z, pag z equals to 0, yung g, yung sigmoid function is 0.5. Okay? Okay, z equals 0, obviously, ito ay magiging 1, kaya ito 1 over 1 half, kaya 0.5 siya nandito. And pag ano na siya, pag nasa negative 4 na yung z values natin, okay, nasa 0 na yung g, and pag positive 4 na yung z values, pwede na natin sabihin nasa 1 na yung g. Okay, and yung hypothesis natin is then written as the sigmoid logistic function. So, ang hypothesis theta of x is equal to the sigmoid function as a function of theta transpose times x. Okay? So, yung z dito, pinalitan natin ng theta transpose of x. Okay? Remember na yung x yung dataset natin at yung theta ay yung weights at saka yung bias. Okay? So now we've incorporated the weights and the bias at saka yung dataset dito sa ating tawag dito hypothesis using the sigmoid function. So basically, pag yung theta transpose of x, pag yung hypothesis is less than 0.5 or yung theta transpose of x okay, is less than 0, di ba? Ito kasi yung theta transpose of x ninyo is less than 0, then ibigay nyo output ay 0. Pag yung theta transpose of x nyo is greater than 0, so lahat na nandito, then ibigay nyo output ay 1. Okay? Okay, so ganun siya kasimple. Okay, so if we plot the sigmoid logistic function against this graph, okay, we now have this tawag dito, we now have this result, di ba? So, mapapansin nyo na, halimbawa, ito ang tumor size. Pag pinoject nyo yan dun sa model, okay, so nandito siya banda. Okay, but remember, if it's less than 0.5, it will output na y equals 0. So, automatic na sasabihin niya sa'yo na y equals 0. If it's greater than 0.5, so halimbawa, ang tumor size is this, and greater siya than 0.5, then ibibigay niya output sa'yo is 1. Okay, so makikita nyo na sigmoid logistic function is well suited para sa classification. Okay. Okay. Okay, now let's talk about what's called a decision boundary. Okay, now this is also another type of classification, obviously, di ba? But of course, pag nakuha nyo kasi ang isang data, hindi siya ganun ka-obvious. Okay? I mean, ito, ginawa na siyang obvious by, anong tawag dito? By plotting itong mga data na to na circles at itong data na to as x's. Okay? But when you get a data, hindi kayong magde-determine kung alin yung circles at x's, di ba? So, ang tawag dito, the way for you to determine that is through visual inspection kung kayo yung gagawa. But of course, if you want to use machine learning, gagamitin nyo ito ng tinatawag na decision boundaries. Okay, let's say na ito yung hypothesis natin. Okay, this is nothing but theta sub t times x. Okay, theta sub t times x. Okay, walang pinagbago yan sa ginawa natin before. Now, ang x1 is one feature, ang x2 is another feature. Kaya ang x1 ay merong weight na theta sub 1 at ang x2 ay may weight na theta sub 2. And then itong theta naught is the bias. And then of course, meron tayong x naught dito, pero yung x naught is just equal to 1. If we're going to use sigmoid function, then g of theta sub t times x is essentially your hypothesis. Okay, let's start with this hypothesis. Okay, ito yung initial na guess natin. Sorry, hindi hypothesis. Ito yung initial na guess natin for theta. Negative 3, 2, at saka 3. So which means na ang theta t of x is negative 6. Okay, negative 6. Okay, plus 2, but negative 6 to? And this should be negative 6, sorry. Ito ay negative 6 dapat. So negative 6, 2, at saka 3. Okay, ito yung theta 1, theta 2. Tapos ito ay negative 6. Okay. Okay. Greater than, if this is greater than 0, then we call, then lahat niyan ay y equals to 1. Okay, so tignan natin. 2x plus 2x sub 1, i-rewrite lang natin ito equation na ito. Okay, 2x sub 1 plus 3x sub 2 is greater than or equal to 6, then y equals 1 siya. Okay, so yan yung ating tawag dito. Line, okay, na nakuha natin from this. Okay, okay, madali lang yan makukuha kasi set nyo lang yung x2 to 0, then yung x1 is 3. Diba? X1 is 3, ito yun. Then set nyo yung x1 to 0, then yung x2 is 2. So yung x2 is 2. Okay, so makaka-drawing na kayo ng line. Okay, now, this line is called the decision boundary. Okay, so, obviously, yung decision boundary is not the correct decision boundary. Okay, kasi hindi niya sineseparate yung circles from the x's. Lahat ng sa taas ng line lahat ng nasa kaliwa o nasa kanan ng green line na ito is tawag dito, should be classified as y equals 1 or as x's. At lahat ng nasa baba should be classified as y equals 0 or yung circles. Pero may isang circle dito na hindi siya na-classify ng tama. Diba? So, ibig sabihin, mali itong guess na ito. Okay? Okay, so, tignan natin. Ito na ngayon yung ating hypothesis. Okay? So, syempre, gagamitan na natin ito ng code, di ba? So, if x1 is equal to 0.5, palitan natin ito ng 0.5, palitan natin ito ng 0.5, ang ibibigay niya sa ating h theta sub x is 0.029. 0.029. Asa bang 0.5, 0.5? Ito yun. Okay, so tama siya, di ba? Okay, x1 is equal to 2, x2 is equal to 3, x1 is equal to 2, x2 is equal to 3. So, nandito siya. Ito siya. Ito siguro dito yung data point. Okay? At yung hypothesis is 0.99. So, tama. Na-classify siya correctly. Okay? Now, yung x1 equals 1 at yung x2 equals 1.4. 1.4 is somewhere here. H theta of x is equal to 0.550. And obviously, dahil greater siya by 1, dapat siya i-classify as y as x. Pero dito, it's classified as a circle, as a circle, di ba? So itong data na ito, itong point na ito is classified incorrectly. Okay, now what if we change yung tawag dito, yung ating theta to negative 311. Okay, so again, theta t of x is negative 3 plus x1 plus x2 greater than 0. Yan ay magiging equal to sa 1 dapat. Okay, so i-rewrite lang natin to. So x1 plus x2 is greater than or equal to 3. Okay, and madali lang natin ma-draw yung decision boundary dyan. So if x2 is 0, x1 is equal to 3. So ito yun. And then if x1 is 0, then x2 is equal to 3. Then ito yun. So magdodrawing lang tayo ng line that connects itong 3 na to tsaka 3 na yan. So ito na yung ating decision boundary. Makikita natin na itong guess na ito is much better than the previous guess. Okay? So, tama ito, di ba? 2, 3, ito yung 2, 3, ito yun. And then tama rin ito. 0.3, 2.2. 0.3 somewhere here, and then 2.2 is somewhere here. Makikita natin hypothesis is 0.375, which is less than 0.5. So it was classified correctly. Okay. Now, there are some decision boundaries. Okay, so now there are some data set pala. Okay, na ang decision boundaries ay hindi ganun ka hindi straight line. Like for example dito, circular, okay? And you can create these decision boundaries, okay, by kung titignan nyo, yung x is not ay hindi na lang power ng 1, kundi power din siya ng 2, and then meron ding cross product ng x1 tsaka x2. Okay? Hindi lang yun, meron pang cross product ng powers ng x1 at saka ng x2. Okay, so the more complicated yung hypothesis, okay, you can make a decision boundary that's also tawag dito, more that will model your data better. Okay, so dito very simple lang yung ating tawag dito, yung ating hypothesis. Okay, we draw a straight line, but if you want to draw decision boundaries na ganito, ka-complicated, then you will need to have higher orders of x, okay, and even yung tawag dito cross products nila. Okay, so this is okay. Now binabanggit ko to kasi there's a problem with choosing tawag dito. Kasi you can model this as much as you want, okay, para maging perfect. Okay? So halimbawa gusto nyo itong plus na ito isama dun sa loob ng green, itong plus na ito isama dun sa green. Okay? You can do that by manipulating itong nandito. And if we do that, okay, ito yung lalabas. Okay? Now, ito yung decision boundary na lalabas. Now, if we use this decision boundary, itong model na ito will only work for all of these data points. Now, the problem is, paano kung nag-generate kayo ng bagong data points? Yung bagong data set. Okay? So, itong data set na ito is called the test data. Okay? Okay, so dito nyo minomodel, dito kayo gumagawa sa test data, gumagawa kayo ng tawag dito ng model. Sorry. Ano na nga? Test data validation. Dahil nakalimutan ko. Dali ah. Training, sorry. So, yun. Oo nga. Okay, balik tayo dito. Apps. Share. Okay. So, again, so itong data set na ito, na kung saan na-develop nyo itong model na ito is called the training data set. Okay, now, if you have a new data na gusto nyong i-test dito, ang tawag nyo dun sa data na yun is a test data. Okay, the test data set. Now, dahil pinerfect nyo yung model dito sa training data set, it could happen na yung test data ninyo, yung bago nyong data, pag pinasok nyo rito, ay hindi mag-fit sa model. So, ang tawag dito is overfitting. Kasi it's so perfect dito sa training data, but it's no longer applicable, not necessarily applicable dun sa test data. Okay? So, yun yung problem, yun yung isang problem pagdating sa machine learning. If you choose, tawag dito, certain parameters, you might overfit yung model. Okay, now, kung kulang naman yung, tawag dito, yung pinili nyo na parameters, kung kulang yung pag-develop nyo ng model, tawag naman dun is underfitting. And underfitting is nothing but, okay, this model, okay, at itong lahat ng mga mistakes na yan. So, when you do underfitting, okay, ibig sabihin, hindi nyo na-train yung model nyo ng maayos. Okay, now how do you correct this overfitting tsaka underfitting? So basically, reduce niyo yung number of features. In the first place, kaya naman kayo nag-overfit, di ba? Kasi dinamihan niyo yung mga features na ito, di ba? This is one feature, this is another feature, ito isang feature din yan, and so on and so forth. Okay, yun lang, kailangan yung i-select manually kung ano yung mga features na i-keep. So trial and error ang gagawin niyo dyan. And then you can also do this method, which is called regularization. Okay. Okay. So we'll not go dun sa details ng regularization. I'll just keep this slide. Okay. I'll just give you these slides. Okay. And then kung gusto niyo pag-aralan kung ano yung mga yon, meron ding reference. Ako na ipoprovide. Okay. Kasi gusto ko na mag-move dito sa kung paano natin i-implement itong tawag dito itong sigmoid function. Okay, sigmoid function or tawag doon, sigmoid tsaka logistic function. Okay, sa gradient descent. Okay, so yun na yung gagawin natin. Okay. So, ito na yung gagawin natin. Sa linear regression, ito yung expression. Okay? Dahil gumagamit na tayo ng sigmoid, i-rewrite na natin yung cost function as this. So sum, okay, ng cost, okay, of this is equal to tawag dito, times 1 over m is equal to the cost function. Ngayon, ano tong cost na to? Itong cost na to is just 1/2 of this. Now, kung iisipin niyo, pag pinasok niyo doon, okay, pareho lang naman dun sa linear regression. Okay, well, in shape, it is. Diba? Pero remember na yung h theta x nyo is now equal to g of theta transpose of x, which is the sigmoid function. So ito, hindi na siya yung linear na expression nyo before, but this is replaced by this sigmoid or logistic function. Okay? Okay. Now, there's actually tawag dito a variation, okay, for the sigmoid or logistic function. It's called the logistic regression function. Okay, so imbis na ito yung, well, gagamitin pa rin naman natin ito, but we will write this cost function, okay, itong buo na ito, instead of writing it like this, we're going to write it as this. Okay? Kasi magiging simple lang yan. Kasi tignan nyo, negative log of h sub theta of x, yung cost function is equal to negative log of h sub theta of x if y is equal to 1. And then if y is equal to 0, then it's just equal to negative log 1 minus h sub theta of x. Okay, so yung shape nitong log na ito is this. Okay? At yung shape nito is this. Okay, so yung cost. Okay, so if tawag dito, ito yung h sub theta of x natin, ano? So ito siya. Okay, or yung g essentially, di ba? And if G is less than 0.5, then ito yung value niya, di ba? And if G is greater than 0.5, then ito yung value niya. Wait, if G is greater than 0.5, then tama, dapat ito. Ito yung value niya. And then if G is greater than 0.5, then dapat ito yung ulit. If G ito yung G, di ba? So, if G is greater than 0.5, okay? So, halimbawa 1, so ang log ng 1 is 1, okay? And then if G is less than 0.5, then this is 1. Ito yung magiging log ng 0, so 0 siya. Okay, so ganun yung nangyayari. Okay, so yan na yung cost function natin. Now, hindi madaling i-implement ito, okay, unless na isulat natin siya as this. Okay? So, very simply, okay, if this is not, if y is equal to 1, so 1 ito, then ito 1, so itong term na ito mawawala at ito lang yung matitira. And if y is equal to 0, then mawawala itong term na ito at ito yung matitira. Okay, so yun yung ano niya. So ngayon yung ating cost function is written as this, where this is this. Okay, so ganyan na yung itsura ng ating cost function. Okay, next step, kukunin yung derivative. And it's actually much simpler than you think. Yung derivative, of course, alam natin ganito yung form, yung ganyan yung H, hypothesis, and then yung tawag dito, yung implementation ng gradient descent is this, okay? Now, just to compare, ito yung linear regression, ito yung logistic regression, ito yung cost function sa linear regression, ito naman yung, and then yung H sa linear regression. Ito yung cost naman sa logistic regression, ito naman yung H sa logistic regression. Okay, ito yung ating implementation ng gradient descent, and it's the same for both. Okay, and ito yung tawag dito. Well, this is the gradient descent na nire-write lang natin yung H of theta. Okay, na ganito. Pero basically, kung titignan nyo, yung code, okay, is the same for both linear regression at logistic regression. Ang nag-iba lang is itong H at saka itong cost function. Okay, so sa MATLAB, ganito na yung implementation niya. Okay, so ang tatawagin natin siya sigmoid function. Ang sigmoid function is this one, 1 over 1 plus exponential minus theta sub t of x. Okay, and yung cost function natin will be this. Okay, so 1 over m times sum ng negative y log ng h minus 1 minus y ng log times log ng 1 minus h. So ito siya. And then, yung h is the sigmoid function. Ito yung sigmoid function. At yung kukunin natin yung sigmoid ng x theta. So ito yun. Okay, and then finally yung gradient descent. Okay, tignan nyo yung gradient descent dito. It's exactly the same as yung gradient descent dun sa linear regression. So walang nag-iba. Ang nag-iba is yung h, okay, at yung cost function. Okay, so yung cost function dito, yun lang yung nag-iba. Okay, so oops, hindi ko pinakita yung code sa Python. Okay, so now let's go to MATLAB. Classification. Okay. Okay, so classify natin kung malignant or hindi yung tumor. So pag linear regression, ganyan yung lalabas. Okay. Pag nagdagdag tayo ng data, ganyan yung lalabas. And ito ang gawin natin. Okay, anong error dito? X. Recognized. Wait. Z. Z kasi. Yan. Okay, so yan naman yung logistic regression. Sorry. Okay, this is another example of application of logistic regression. Okay, so dito, exam 1 score versus exam 2 score. At tinitignan niya kung ano yung, anong tawag dito? Kung ano yung, kung admitted siya or hindi. Okay, so ang classification dito is admitted or not admitted based on the exam score. So dito gagawa siya ng regression lines, decision boundary na linear. Okay, and then apply natin ngayon yun. Okay, so ito na yun. Yan. Ito na yung decision boundary na linear. So anything above the decision boundary is admitted and anything below is not admitted. So based on the exam score. So that's another example. Now here's another example. Dito naman, ang pinapakita dito ay microchip test so sa semiconductors. Okay. So okay, then we plot the decision boundary. Okay, so ganito yung itsura niya. Okay, we can manipulate, for example, yung lambda. Yung lambda dito is the parameter that changes the regularization, where the regularization is applied. Okay, so pag tinaasan natin yung value. Okay, so medyo malaki na yung decision boundary. So we have to fine-tune yung value nito para mag-fit lahat ng para tumama yung decision boundary. Okay, so something you can play around pag sinend ko na tong data na to. Okay? So, yan. So this is how we implement tawag dito. Tawag dito. Classification. Machine learning to classify yung dataset. Okay. So, next meeting, ang i-discuss na natin ay neural networks. Okay, kasi for neural networks, okay, we needed yung concept nung multivariate, okay, na diniscuss natin kanina. Okay, and kailangan din natin yung sigmoid tsaka logistic function na diniscuss din natin kanina. Okay, so now that we've discussed those, pwede na nating pag-aralan yung neural networks. And when we discuss neural networks, we'll take a look at yung example. We'll proceed with what are called convolutional neural networks. Okay, and then doon na tayo magka-classify ng mga objects na present sa isang image. So we'll work on images next meeting. Okay, so any questions? Okay, so kung wala nang tanong, then I'll see you again on Tuesday. Okay? Have a nice weekend.